Welcome back to the Automation Podcast. My name is Sean Tierney, and this week on the show, I meet back up with Sean Foley from Banner Engineering to learn about 8 advantages of using IO-Link, as well as learn about some of Banner's new IO-Link products. Sean, welcome back to the Automation Podcast. I am excited to talk about IO-Link with you this morning and a new product that we're going to talk about a little bit later. But before we get started, in case somebody hasn't caught previous podcasts with Banner on it, could you introduce yourself to our audience?
Yeah, absolutely, Sean. It's really fantastic to be back on your podcast. I've been following the automation blog for years, and I've learned so much of your content. So it's a real honor to be here again. So my name is Sean Foley. I'm a part of the product management team here at Banner. Worked with IO-Link over the years for about 7 years. Really excited about this technology and really excited to share some of the things I've learned about IO-Link, some of its advantages, and also introduce some new products from Banner that could really add some value to a lot of these IO-Link applications. So really, really excited to be here.
That's excellent. And I just want to thank you for your kind words. And, I love learning about new technology, and I know the audience does too. So we're looking forward to it. I may step in if there's something visual that, we may have to explain, or you can, for our audio audience. Our audio audience is really growing. So
Yes.
if there's anything we have to do, we'll do that there. But thank you for the kind words, and let's jump right into this presentation.
Thank you so much, Sean. Yeah, so today we're going to be talking about IO-Link and some of its advantages and reasons to use it. So I've worked with IO-Link for a number of years, and I've seen its tremendous success. And I want to share some of the insights I have found with IO-Link in discussions with automation professionals through the years, and also in helping some of our customers deploy it. And why it is an extremely powerful technology and cost effective for a ton of reasons. So I first started hearing about IO-Link right around 2014. And when I first came into contact with IO-Link, I thought, oh wow, it's a really cool way to kind of configure sensors. That's what I thought it was, but I realized it is so much more than that. And so that's what we're going to be talking about today, talking about IO-Link, some of its advantages and reasons to use it, tips and tricks I've learned over the years, and also introduce you to some new products that Banner's released with regards to IO-Link that can be real problem solvers, and also introduce our new IO-Link Master, which has a multi-protocol interface. So before diving into the advantages of IO-Link, Sean, I want to quickly, briefly talk about what exactly is IO-Link. So in a nutshell, IO-Link is a standard point-to-point communication between an IO-Link master and an IO-Link device. And it's important to note that IO-Link is not a field bus. So an IO-Link system is quite simple. It consists of an IO-Link master and just one or more IO-Link devices. IO-Link also runs on a standard 24 volts DC, which means, and this is huge, you only need to use 3-conductor standard unshielded M12 cables. That's one of the big drivers why people, especially OEMs, have started adopting IO-Link, is because they're able to standardize on that nice M12 connectivity. Another thing before I move on is that there's a distance of 20 meters. You can run up to 20 meters between an IO-Link master and an IO-Link device. And this is the last piece before I move on, is IO-Link is not proprietary to one sensor manufacturer. In fact, IO-Link is made up of a consortium of over 400 members, and members are always being added to the consortium. So together, all of these members of this consortium, many of these companies you probably recognize, there's Banners right in there. All of these members came together to create an easy to use, low cost method in which sensors can send more data than just a switching output. So if you go to iolink.com, you'll be able to find more information on the consortium, as well as kind of more information on IO-Link. And you can see on the slide here that the number of IO-Link devices deployed throughout the world has grown and skyrocketed exponentially over the years. As you can see on the slide, we're at over 27 million IO-Link devices out there, IO-Link nodes. Another thing that's really interesting is that it's going to continue to grow exponentially. It's expected to grow over 23% year over year until 2027. And so today, instead of continuing to talk about IO-Link, we're going to be talking about some of the reasons why IO-Link has grown and some of the reasons to use it.
Now, before you leave that slide, I want to throw out a couple things. For the audio-only audience,
pretty much all the major vendors you know of in industrial automation space, including Banner, are on the screen right now. Okay. And the other thing, I want to throw out too is when you're ordering your sensors these days, they may already have IO-Link built in. A lot of sensor manufacturers just now ship only IO-Link because it's so inexpensive to enable inside the sensors. So keep that in mind. You may already have IO-Link in your plant, even if you're not using it. So I just
That,
wanted to jump in and say that.
that's a fantastic point. I'm so glad you brought that up. Yeah, many people have IO Link on their devices and they don't even realize it. They might be using a traditional IO system and they have all these IO Link devices already installed and they're not using IO Link. Um, and so you only actually need a couple of components to get an IO-Link system up and running. You need an IO-Link device, an IO-Link master, and a cable between them. And like I mentioned before, that cable is going to have a maximum length of 20 meters. And so what's unique and powerful feature of IO-Link is that you don't need any specialized cabling, just a standard 3-wire M12 cord set in a lot of cases. Um, and so if you look at that image there, Sean, there's kind of a cutaway of an M12 cord set. Um, if we look at applications throughout history, if we look at all the discrete I/O and traditional I/O systems, if we simplify a traditional discrete I/O point that's been used for years and years, inputs just measure if voltage is present, and outputs trigger an external action via a PLC or some sort of controller. And there are tons of applications out there that have started out just like this, just a simple on and off coming from a proximity sensor or other sensor going back to a controller. But then we start turning on and off those signals in agreed upon patterns to send more data than just a 1 or a 0, almost like Morse code. And IO-Link is that legacy continuing by taking that 24-volt signal on the digital I/O point and turning it on and off in agreed upon patterns to send more data than just a 1 or a 0. So on the slide here, Sean, we're showing an IO-Link master, the Banner's new IO-Link master, and an IO-Link sensor. It's a Q4X photoelectric sensor. So this could be connected to your IO-Link master. And in this case, instead of just sending a 1 or a 0, it could be saying things like the target is 2 meters away from me. The Q4X could be saying, this is my vendor ID, this is my firmware. Oh, and by the way, my lens is starting to get dirty, so you might want to wash it. You're able to send a lot more data than just a 1 or a 0 when you're using IO-Link from your sensors. So that enriched, powerful data that helps keep your systems up and running optimally is available with IO-Link.
It's if we look at the late 90s and 2000s, we started to see like photo eyes, right? With margin indication and like with little displays on them where you could actually program them and do neat things and get additional information out of them. But before IO-Link, they were still just sending an on or an off to the controller.
Yep.
So to me, it's kind of exciting because I've kept seeing all the sensors getting all this advanced features, and I had to go down to it and actually plug it in and hit all the buttons that set things up, and there was no way to get that detail back into the controller. But IO-Link unlocks that. It says, hey, this intelligent sensor you have, now that data can come back. In many cases, you could actually configure via software one of these sensors over IO-Link. So that's what got me excited when I first saw it. And this graphic does a good job of kind of showing how replacing the digital with that pulse train and how that works. So thank you.
Yeah, absolutely. And that's a great point. And the actual IO-Link master that we're showing in this slide, there are many IO-Link masters out there. Banner's launched a new multi-protocol 4-port IO-Link master that's really been a game changer for a lot of our customers. As you can see, it's kind of as a very unique form factor. The connectors are coming out at the bottom there as opposed to many IO-Link masters on the top. So this IO-Link master, it's a 4-port IO-Link master. As you can see, it has the 4 IO-Link ports at the bottom. It is Ethernet, IP, Modbus TCP, Profinet, and Modbus RTU communications. And also, if you look on that 5th port there in the upper left, that's actually a Modbus RTU port. So you can, in addition to connecting IO-Link devices on those 4 ports, you could actually add a Modbus RTU network on that 5th port there. So you could really expand and add more devices than just IO-Link. So we've been able to solve a ton of different applications since we've launched this in July. It's really seen a lot of success, and these are readily available for your IO-Link projects, ready to go. So if you have a need for an IO-Link master, this is a great option.
Now, you're saying this one device, one part number, supports Ethernet IP, Profinet, and Modbus TCP. Did I understand that correctly?
That is correct. Yep. The part number is the DXMR90-4K. It's a
And you've
multi-protocol IO-Link master.
That's awesome. And you found a way to also put a Modbus port on it, a Modbus RTU, which is the popular Modbus.
Yep, exactly. On the left there, on the left side of that IO-Link master on this image, there's a Modbus RTU port, and that's been a real kind of unique feature of this IO-Link master. So being able to add things like perhaps condition monitoring that you want to send back to your control system. Maybe you want to add vibration sensors. Use converters, some of our existing converters, to convert things over and connect it to your Modbus port, vibration, temperature, humidity. It enables us to do a lot of interesting things with that Modbus port and also add a lot of devices. So with Modbus, you could tee into lots of devices on your Modbus network and bring it back to your control system.
Absolutely. And I'm not trying to steal your thunder. Is it 232 or 485?
It's 485. Yep.
Which is typically what you have with Modbus RTU.
Yeah.
Excellent.
Exactly.
Wow.
Yeah, so it's been a really exciting time. A lot of fun working with some of our customers and deploying this. And in addition to that, so with the Modbus RTU port that I was talking about before, we also have these two IO-Link masters that you see right here, the 2-port and 4-port, and that these actually have Modbus RTU coming out. So these two IO-Link masters, you could actually connect on that 5th Modbus port. So if you want to add more IO-Link devices and have that one Ethernet connection going back to your control system, you could actually add these to that Modbus RTU port on that IO-Link master. So these are serial IO-Link masters. So as you see it, as there's a 2-port, so you could connect 2 IO-Link devices, and on the right there's a 4-port. On that male connector, you have that RS-45 or Modbus RTU communications going out. So these are 2 of our other IO-Link masters that play really nicely with the one I was showing on the previous slide, which has Ethernet IP, Modbus, TCP, and Profinet coming out.
So you're using the Modbus port to expand how many IO-Link devices you can connect on one Ethernet drop, whether it be Ethernet IP, Profinet, whatever. Wow.
Yeah, so it's really cool because then you could actually have multiple IO-Link masters. You could tee into multiple of these IO-Link masters on that Modbus RTU port I was showing before, and that's been used quite a bit.
That's awesome.
Yeah. Also, Banner's a lot of different IO-Link sensors that are out there, including our photoelectric and fiber optic and measurement sensors. We've been in the IO-Link sensor world for a long time. Additionally, with some of our really cool lights. I love these lighting products. They're available in many different form factors and configurations. What IO-Link enables us to do is do some really cool custom animations and colors to fit unique applications with some of these lighting products on strip lights, maybe doing things like tank level, our tower lights, our IO-Link touch buttons, and also some of our IO-Link indicators. And that's what's shown on this slide, just the different form factors and lights of that Banner has. And many of you might be familiar with some of these or seen these out in the field. We have many different IO-Link products.
Yeah, this is just for the audience. We did a whole podcast on this. This is a cool line of, everything from stack lights to strip lights to indicators to, buttons. And I mean, check it out.
Yeah, I saw that great progress with Rob Wiedemann. So yeah, be sure to check that out too. So now I talked a little bit about some of the IO-Link products, and I'm going to dive into some of the reasons to use IO-Link and some of its top advantages. And I've seen these pop up over the years, time and time again. And I wanted to share some of the things I've learned over the years and some of the top advantages. And John, feel free to chime in along the way, as I know you've worked a lot with IO-Link over the years and have some awesome experience with the technology. And the first advantage I want to talk about when you're saying, why use IO-Link? What are some of its advantages? This is probably one of my favorites. It's seamless and simple device replacement. So with data storage mode, or backup and restore mode as it's often called, the device configuration of your IO-Link sensor is saved on a port of the IO-Link master. So essentially, an untrained operator or an operator who's using these sensors can replace the sensor, and the correct device configuration is loaded automatically. As we all know, there's tons of devices and sensors out there that have virtually infinite configurations. And so if lo and behold, a forklift driver was to, run over your IO-Link sensor, with data storage mode, you simply remove the sensor, plug in a new one, and you're good to go. It makes device replacement completely hands off. I've had so many conversations and discussions with automation professionals, and I asked them, have you ever had a device in the field that gets damaged, and you have to go out there and print out the manual and try to configure it like the last one and kind of hope it works. And I get the knowing stare. It happens all the time. Some of these sensors have virtually infinite configuration possibilities. And with IO-Link data storage mode, you can store the configuration on the IO-Link master, plug in your new sensor, set it and forget it, and it's completely hands off. And so that's one of my favorite advantages. And Sean, do you have a lot of the IO-Link users you chat with? Have they taken advantage of this feature? So sometimes I chat with like OEMs, and they really like this. But I'm curious, some of the IO-Link users you have chat with, have they taken advantage of this feature?
Well, I got to be honest with you. There is a hesitancy with auto device replacement because a lot of vendors have it, but it's clunky. But to people using IO-Link, think about it, right? This is not like, you have like 10 different firmwares and, there's all this complicated stuff that could stop it from working. We're talking about photo eye sensors, lights, all kinds of simple devices. So you definitely want to use this. It's not, again, we there's this stigma against automatic device configuration or replacement, and but with IO-Link it actually works, and it
Yeah.
does because these are simple devices. It's not like you have to worry about the series and rev and firmware and all the other things that kind of ruined it back in in legacy networks like DeviceNet and other products. So that would be my message to people, because I think a lot of people avoid using it because they don't think it's going to work.
Yeah. Yeah, that's great. That's a great point. And I've seen this used a lot with, OEMs, and they're standardizing on certain sensors, and they just makes things so much easier when they're going out and replacing devices and sensors on some of the machines. Um, Another advantage I think with IO-Link is this is a big driver for many people who are switching over from traditional IO systems to IO-Link is the ability to standardize and reduce wiring. So with IO-Link, all the devices use the same unshielded cables. Again, like I was talking about, it's a digital signal. So more often than not, it'd be unshielded, standardized M12 cables. And what this means is, in most cases, replacement cables or parts now only vary by length. You could just standardize on M12 connectivity, 3-conductor across the factory, cables that are easy to access in your bins. And now you just don't have to worry about having these big bulky cables anymore, like your M23 or 19-conductor cables. And what this often means too is no more wiring or pinout mistakes, more cost-effective and readily available cabling. And this is big, much faster installation times. And this is one of the big reasons I've seen many users switch to IO-Link. And a great way to save money in many applications is the replacement of passive junction blocks with IO-Link hubs. So there are many junction blocks out there that take in discrete signals and have a bulky kind of multi-conductor 19-pin home run cable going back to their control system, and they have to land every wire on their discrete inputs on their input cards in their control cabinet, and that leads to large control cabinets, and inevitably there's going to be some wiring errors over time. So I remember a conversation with an OEM who switched from a traditional IO control system on his machines and standardized kind of on IO-Link. And so by being able to standardize on IO-Link, he switched to using discrete IO-Link hubs. And so being able to replace these junction blocks with these IO-Link hubs, here are just some of Banner's IO-Link hubs that are shown. We have 3 different versions. There's the 8-port and the 4-port. Each of these IO-Link hubs has M12 ports, and each of these hubs on each of those ports can take in 2 discrete inputs, either an NPN or a PNP. And the reason why these are a great option replacing some of these junction blocks with the 19-conductor cables is, instead of having all 19 of those wires going back to their control system, we have these hubs going in with a standard 3-conductor M12 cable into the IO-Link master that you see at the top of the slide here, and then just having one Ethernet connection going back to their control cabinet. And so this has been a a big help for many end users or customers who are using IO-Link is being able to replace their junction blocks and standardize on these IO-Link hubs that you see here. And so these are an excellent option. Our hubs too are stackable, so that's another unique feature of some of Banner's IO-Link hubs. If you're in an area perhaps where space is at a premium, you want to bring discrete I/O back to your control system. You could actually stack these hubs, these IO-Link hubs from Banner on top of each other with their mounting bracket. So another option with these. And really what it comes down to is being able to reduce wiring with IO-Link, to reduce the installation time to install it, the complexity, and to ultimately avoid this. So you see kind of in this slide here, Sean, kind of a messy control cabinet. All these wires going back from a traditional I/O system going back to the control cabinet. You see installations like this all over the world where there's just a huge control cabinet, all these wires individually landed. And with IO-Link, you could really simplify this and make your control cabinet a lot smaller by using IO-Link hubs and standardizing on a decentralized I/O system using IO-Link. And I remember kind of the conversation I had recently with an OEM who switched from a traditional I/O control system on his machines and standardized on IO-Link. And he told me, Sean, I went from having over 1,000 wires going back to my control cabinet that we would have to land individually for each machine. And so I went from that to only 6 Ethernet cables when we switched to IO-Link. So it's been a game changer for him and others, not just on cost savings on the cabling itself, but just on installation time and speed. And as we all know, time is money. And so this has been a big driver for switching to IO-Link, wire simplification. And OEMs in particular love it, but many others do too. And Sean, have you seen kind of this being one of the key drivers as to why many are switching to IO-Link systems in your experience?
Yeah, if we go way back, people started adopting distributed I/O for similar reasons, right? Because it's just insane to try to run everything back to one control panel. But now a lot of what is out on those I/O drops are sensors and devices that are perfect for IO-Link. And the time it takes, and I know a lot of companies don't look at time as being free, and it's really the cost of materials, but time is not free. And I've seen some great presentations by OEMs who have just switched from hardwiring everything, getting the sensors with pigtails and hardwiring everything to going to the slightly more expensive cord sets, right? And how much time, especially in troubleshooting, that they
Yeah.
have saved. I mean, I've driven 3 or 4 hours to troubleshoot an IO card where the elderly guy who was wiring their panels just was not screwing down the screw heads hard enough, and so the wires were just kind of hanging there, not connecting. So
Yep.
this is real, and now eliminating. I mean, IO modules that they're not inexpensive, and if you have sensors or IO link compatible devices at that drop, it's like, hey, I'm running Ethernet there anyways, right? So look at IO link, because the one thing you're going to miss by hardwiring your sensors, being able to do all that, the smarts, being able to configure it and get all the additional information out of it that you just won't get when you hardwire the sensor for on and off.
Exactly right. That's so true. That is a great point. Talking about some more kind of advantages, this is a big one. IO-Link in a lot of cases can actually replace analog. So with IO-Link, you can avoid costs associated with shielded cables and also on analog input cards if you switch from analog to IO-Link. So by using the IO-Link process data on the device as opposed to the analog output on the device, you can avoid the digital to analog and analog to digital conversions and provide the highest quality measurement that is robust digital signal that's immune to noise. And this means you don't need to use shielded cables anymore. And by switching to IO-Link, we've seen on average analog costs reduced by 15 to 25% in terms of savings on hardware. And so that's another big advantage where people may have an analog device that already has IO-Link on it. This is the case where some people may have an IO-Link device and not realize it, and they could switch to IO-Link. And so there's another thing I like to talk about, and another advantage is people think, well, what if I don't have IO-Link? What if I want to connect non-IO-Link devices? I want to standardize on IO-Link, but I don't have, I have several IO-Link or non-IO-Link devices out there. Well, that's not a problem because Banner has these IO-Link converters that you see right here that allows you to connect these non-IO-Link devices to your IO-Link master and get it onto the IO-Link communication chain. So these little converters that you see, there's an image there that shows one installed, are about the size of a AA battery. And Banner has over 30 different models available depending on what type of signal you want to convert. So you could take in signals like your 4 to 20 milliamp, your 0 to 10 volt, your NPN or PNP signals, Modbus signals, convert those signals over to IO-Link and connect them to your IO-Link master. So that's a concern that comes up, but it's really not an issue with these IO-Link converters. We could allow you to connect these non-IO-Link devices to your IO-Link master. And so what this also allows you to do is to utilize open IO-Link ports. So you could connect, if you wanted to say connect a non-IO-Link vibration sensor or a temp and humidity sensor, you could connect that to your IO-Link master without a problem and utilize those open IO-Link ports that you see right there. So another thing is Banner has converters that could also allow users to drive analog outputs from the IO-Link master. That's kind of what's shown in this slide here. We have an IO-Link master, and we have one of our IO-Link to analog output converters. Now what this does is essentially you could connect this converter to an IO-Link master. It could be any IO-Link master. And you have the ability from your IO-Link master to drive analog outputs on things perhaps like a pneumatic actuator that's controlled by a 0 to 10 volt signal. And you want to connect that to your IO-Link master. Well, we have these IO-Link to analog output converters that have been deployed all throughout the world for solving these unique applications. So for both inputs and also driving outputs, there's converters out there that'll solve the concern and address the concern of, well, I want to standardize an IO-Link, but I still have non-IO-Link devices out there. These help ease that transition.
A couple of case points that came up to me while you were talking was, number one, if you have analog that you're having a lot of noise issues with because it has to run, through an area that's very noisy, right? That's one place where converting it at the source to IO-Link would help alleviate that noise that riding on that analog signal. And another thought I had too is like some of these IO cards, right? Especially analog clock cards, they've seen very, very long lead times.
Yeah.
I know I work with multiple vendors. I teach at the automation school, and I actually was picking up stuff on the used market because I had to do lessons and I couldn't get the new stuff, and so you can avoid that if you're finding like particular XYZ analog modules being tough to get, by converting it to IO-Link. Now you don't have to worry, maybe you had standardized on line A and line X, is what the vendor's pushing today. So line A is hard to get. This is one way to kind of eliminate that hard to find analog module, whether it's in or out, because you're just, standardizing on IO-Link.
That is so true. Yeah, as we've seen it kind of time and time again, analog inputs they're so difficult to get lately.
Yeah.
And by using an analog to IO-Link converter and plugging it in just to an unused port in your IO-Link master, you can solve this issue of bringing analog inputs back to your control system, like you said. So that's just such a good point on the IO-Link side with being able to solve kind of those unique applications where some things are difficult to source. It's a great problem solver. Also on, we have our IO-Link hubs, and there's IO-Link hubs out there that allow you to bring in discrete sensors. So we have 3 different versions. We have the 1 port, the 4 port, and the 8 port. And on each port of this hub, on these hubs, you could take in up to 2 discrete inputs. So for example, on our 8 port discrete hub, if you have traditional discrete NPN or PNP devices out in the field, you could take in up to 16 discrete inputs on one 8 port hub, bring it back to a port in your IO-Link master. So for example, our 4 port IO-Link master, that allows you to take in 64 discrete inputs and bring it back to your control system. On these hubs too, it also gives you the ability to drive discrete outputs from these hubs as well. So you could drive both outputs, but you could also take in 2 discrete inputs on these hubs. And the nice thing about Banner's IO-Link hubs is that they can do both NPN or PNP. in just one part number. So there's no specialized models for NPN or PNP. These can do both on just one model. So it's a great way for bringing in discrete sensor signals into your IO-Link communication chain. Another advantage I want to talk about really quickly is increased data availability. So this is one of the most exciting things, in my opinion, about IO-Link is that IO-Link incorporates process, service, and diagnostic data for continuous data monitoring and status diagnostics. So process data is the information sent from the IO-Link sensor to the IO-Link master repeatedly and automatically. And the specific information sent in the process data varies by device, and you could kind of learn more about the device if you look at the what's called the IODD of the device, or IO device description. And the data availability that I kind of talked about before with IO-Link is a really powerful advantage that has far-reaching implications. So access to sensor level data, it helps ensure smooth operation of system components. It streamlines device replacement with backup and restore mode, and it can help enable things like optimized machine maintenance schedules. All of these things save costs and they reduce the risks of machine downtime. For example, device replacement can reduce the cost of machine downtime, but also on the diagnostic side of the sensor itself. You can see diagnostic messages from the sensor allowing you to fix the sensor, address the sensor before the sensor fails, or do things like perhaps even wipe the sensor down. You could get those diagnostic messages. A little bit more about the data types that are made available through IO-Link communication. They're categorized as either cyclic data, and that's data that's automatically transmitted on a regular basis, or acyclic data. And acyclic data is data that's transmitted as needed or upon a request from the controller. And so process data, what I was mentioning before, refers to the information that the device reads and transmits to the IO-Link master, such as on those laser measurement sensors I was talking before. That would be like the distance reading on the laser measurement sensor. Process data can also refer to the information that is transmitted to the device from the master, such as messages that might be sent to one of Banner's IO-Link tower lights, indicating which color segments should be lit up. Then we move on to what's called service data, also called device data. And that refers to the information about the sensor itself or the device itself, such as what's the configuration of the device, what's the model number, what's the serial number, what's the device description. And service data can be both written to the device or read from the device acyclically. So you could read in the device configuration, or you could also write the device configuration of the IO-Link device. And then lastly, we've got diagnostic data. And diagnostic data refers to things like I was saying before, like notifications, so there's error messages or maintenance warnings that maybe the device is overheating, maybe my sensor's overheating a little bit, or maybe you have a dirty lens. And this data is being transmitted continuously from the IO-Link device to the IO-Link master whenever one of these events occurs. And that's really powerful. Getting that diagnostic data from the sensor itself, allowing you to fix the sensor or address the sensor before it fails entirely.
I think a lot of people are familiar with like a VFD that has a fault log with everything that's happened. And so this is taking that kind of concept, these IO-Link events, and giving you the ability, for instance, on this screen, there's one that says, all-time run event, or resettable event, or teach complete, or factory status restored. These are things you typically wouldn't be able to extract out of your smart sensors or your smart devices, and IO-Link enables that. So that's really cool.
Yeah, it's definitely the access to that data has kind of opened up a lot of doors and help kind of maintain machines, keep machines running optimally. And even things like I said, with like device replacement is being possible and made available with IO-Link. When you talk about another advantage, you talked a little bit about this, Sean, is the ability to read and change IO-Link device configurations remotely. So you could actually dynamically make changes to your IO-Link sensor, many IO-Link sensors, all 400 members of the consortium, all their different IO-Link devices. You could make changes from your controller. So complex IO-Link device the programming, can be loaded quickly onto the device easily. So you can store configurations on the PLC and upload via IO Link based on things like what's products being run. So a technician could access the PLC remotely to adjust settings on the sensor. So you don't have to go out in the field and touch the programming buttons. You could do this completely remotely, change the device configuration, and maybe even things like I've seen with like recipe control. You can store the configurations for your IO-Link devices, your IO-Link sensors on the PLC and upload different configurations to your device depending on what you're doing in your application. And that's what's called recipe control. So sometimes depending on what product's being run through your system. And that's another powerful feature of this. If you maybe do a product changeover on your production line and it requires a new response speed set point on your sensor, you could do that completely remotely, which
that's huge.
Yep.
That's huge, because I know sensor experts who have spent days in the field trying to get one setting on that sensor. It could be a clear product detection, or it could be a color sensor, or all types of different sensors. And they were trying to find one setting that would work with all products that run down the production line. And a lot of times that's just not possible. The settings that work for product A don't work for product B. And so you typically know what product you're running in the controller. So being able to say, okay, hey, we're running product B now. I need to set the sensor up like this, but now I'm running product A. I need to set the sensor up like that. It's something we're used to with higher end devices like servos and drives, but now we can do it on the lower end devices as well. And I've seen sensor guys in the field with a box full of different products trying to find one setting and one product that would do every product that comes down the line, and it's oftentimes not possible. So that's huge.
Yeah, absolutely. Things like recipe control, we've seen it used time and time again with these IO-Link systems. I'd say Advantage 7 I want to talk about briefly and talk a little bit more about the advanced diagnostics. So with IO-Link, you can establish tasks based on real-time information. So alarms can be set to actually alert personnel to address a sensor before it stops working. So this allows you to use that diagnostic data to make decisions based on real-time information and notify you if that lens is dirty or if a sensor might be overheating. And predictive error detection on the device itself is possible because that process data I was talking to you about before, it's continuously and consistently being sent to the controller automatically. So it makes things like making sure your sensors are healthy a lot easier than it ever was before. Well, before it would fail and you would have no indication of it failing before it happens. Now you could actually take corrective action before it fails entirely. And then we get to like Advantage 8, and I think that this is big, IIoT. So if we talk about IO-Link, the availability of just hugely valuable data combined with vendor independence and that interoperability, it makes IO-Link an extremely useful tool for implementing like IIoT. So with our IO-Link master that you see kind of on the slide, you could connect your IO-Link devices. You could send the data to your PLC or to an HMI via Ethernet IP, Modbus, TCP, or Profinet. But Banner's IO-Link master also has the ability to send data directly to the cloud, such as Banner's cloud data services, which you can find more information on bannercds.com. But this IO-Link master, if you're looking to use IO-Link devices for maybe not control, but also just data monitoring of your critical assets, it's an excellent way to implement it because now you have the ability to use a whole array of different devices in that consortium to fit your data monitoring needs and send that data to the cloud. And that's a huge advantage. And here's just a slide that highlights some of IO-Link Banner's IO-Link products. You got the IO-Link master there on that network and control layer. And then we have some field devices below it. And what if you have a field device that's not an IO-Link device? Well, you could use one of our IO-Link converters that are about the size of a little AA battery that has the nice M12 connectivity. Or if you're using some discrete I/O and you want to convert that over to IO-Link, you could use some of our IO-Link hubs. So now you have the ability to send the data where it needs to go. You could send it to your PLC, your traditional control system, an HMI. You could send it oftentimes to a SCADA system or even to the cloud directly from this IO-Link master. So that's another cool feature of IO-Link master is our ability to send data to the cloud either via HTTPS push methods or via like MQTT, for example.
I know we talked about this previously on the podcast, and I just one of the use cases that always comes to mind is, let's say you have a control system you do not want to touch, you do not want to disturb, either because the engineer has to come from off-site, or it's certified, or it's pharmaceutical, so you have to have everything. You can't make any changes, or else you have to go through a whole process. Or it's an OEM piece of equipment, and they have a maintenance contract, and they don't want anybody touching their PLC. Whatever
Yeah.
the case is, there may be an instance where you, as maybe not the PLC guy or the engineer, but as a production manager, you want some information for yourself. Or maybe you have multiple plants you're watching, and you want to be able to have all this data in the cloud, securely, so you're not exposing the programmable controller to the cloud, right? You
Yep.
just have these sensors that are giving you information, and the ability not only to read information from your devices, but also maybe you would want to turn on a light that tells somebody, hey, I need you to look at this, right? All separate from the primary control system. So I know those of us who are purists were like, well, that's kind of wasteful. I got a PLC here, I can do all that. But there are use cases where it makes sense not to involve the PLC, especially when you go into the cloud and you don't want to worry about the horrors of cybersecurity and the firewalls and everything you'd have to implement to do that safely. So I just wanted to throw that out there. I know we talked about that before, but
Yeah.
I see it as a use case that's very appealing.
Yeah, absolutely. Yeah, we talked on the Snap Signal podcast several months ago. That's also available. We talked a little bit about how you could overlay on top of an existing control system ways to gather data, and the same methodology could be used with with IO Link. And so being able to overlay, put something over the top of an existing control system without touching the PLC, without diving into the code, and gather data is something that's really powerful for a lot of these applications where they want to monitor some critical assets and send data to the cloud so they could continuously monitor that data and make kind of data-driven decisions. And sometimes they want to monitor a few things that are pain points for them. Maybe it's a vibration on a motor or temperature and humidity. Things that are pain points or things that if they were to fail would be catastrophic to their production. And they want to continuously monitor those.
Now, I really enjoyed the Snap Signal podcast we did together previously. For those who may not have caught that, can you like in a word, in a sentence, kind of like differentiate that from your IO Link offering?
Yeah, so our IO Link, our Snap Signal portfolio, it uses a very similar controller as what's shown in the IO Link world, except however, it's based on an RS-45 protocol. So with IO Link, you have all these different devices that may be installed, or you may want to add to a machine to do condition monitoring. Uh, you can convert all of these to a unified serial protocol, like an RS-45 protocol, and connect it to our DXM R90X1 controller, which looks very similar to the IO-Link Master that we have. But this is some other advantages because of those Modbus RTU ports on that device. You could connect lots of different sensors. So I encourage you to if you have a moment to look at the Snap Signal podcast we discussed. We kind of go over that portfolio, and also if you go to snapsignal.bannerengineering.com, it's a website for it. It goes over that Snap Signal portfolio as well. But yeah, I'm glad you mentioned that, Sean, because it does kind of have a similar methodology to kind of what we're talking about: converters, being able to send the data where it needs, but it's just kind of a different variety. This is kind of a slide that actually highlights one of our the DXM90X1 that has those Modbus ports, and this product was highlighted in that Snap Signal presentation. This allows us to do some interesting things with IO Link. You could send using the DXM90X1, you could tee in on one port multiple IO Link masters and have a lot of IO Link sensor data being sent to the PLC via Ethernet IP, Modbus, TCP, and Profinet. And so this is the one that we discussed in that last presentation. But we also have the DXMR90-4K, which is our IO Link master that I talked about in this presentation. And so it's an easy way to gather data from discrete inputs. You could send that data to your PLC using our IO Link hubs. You could also use that fifth port that you see on the left there that I talked about, that fifth Modbus port, to connect more IO Link devices. So we have the 2-port and the 4-port IO Link master with a serial interface, that RS-45 interface. And you could actually extend the number of IO Link devices you could connect on that port. You could also do things like adding vibration sensors. So you could have some of our QM30 VT2 vibration sensors that you could add on that chain. And further down the line, you could have another IO-Link master, the serial interface, the kind of what's shown on this slide, where you have a DXMR90 IO-Link master connected to some hubs and some devices, but also on that Modbus port, it extends that. You could add some even more devices. Also, you could even go, you could do things like adding R70 serial data radios. If you want to send data wirelessly across your factory from another IO-Link master connected to your IO-Link, your DXMR90 4K, it allows us to do some really interesting and unique applications with that serial port there that you see. Sean, thank you so much for taking the time to talk to me today about IO-Link.
Sean, I want to thank you for coming on the show and going through all this. It's exciting to see this new product and to get a refresher and talk about these. I just thought it was very interesting. I kept interrupting you, but I thought it was very interesting to go through those advantages of using IO-Link and what you've seen working with your customers. So I really appreciate you coming on the show, and hope we can do it again sometime.
Absolutely, Sean. Thank you so much. It was my pleasure.
Well, I hope you enjoyed that episode. And I want to thank Sean for taking time off his busy day to come on the show and go through all those advantages of using IO-Link, as well as talk about some of their new IO-Link products. With that said, if you did enjoy this episode, please consider giving us a like and a sub. And if you'd like to follow me or get in touch, you can always do so over at automation.locals.com. That said, you'll also find all of my very affordable PLC, HMI, and SCADA courses over at theautomationschool.com. With that said, I want to wish you all a very happy holiday and a happy, safe, and healthy week. Until next time, my friends, peace.